Hey guys, Mr. Janowski here. I just thought I'd make a quick little video about something interesting I came across yesterday. An interesting idea I saw watching some science YouTubes uh, that led me down kind of a Wikipedia rabbit hole. So here's what I saw. So what we're going to do is compare the conservation laws. If you're in Physics 1, we just did the conservation of energy, and right before that we did the conservation of momentum. So if you look at these guys, obviously they're very similar in form, and philosophically, there's some interesting similarities, but also some differences. So I got this idea. I was watching a YouTube by Sean Carroll. I'm aware that we have a student at Charter Arts also by the name of Sean Carroll. This is a very different guy. This Sean Carroll, I've been watching on YouTube for a while. Yeah, very famous, well-respected physicist at Caltech. He's also the author of several books. These two, The Big Picture and Something Deeply Hidden. I own them both. I have not yet completed either of them, but I don't know. I like the way this guy writes. They're just very long and kind of dense, heady books. Um, Also a YouTuber. So I'll put links to his YouTube channel. Brilliant, brilliant guy. His production values in his YouTube videos aren't much better than mine. But don't let that, I don't know, turn you off of the brilliance of his ideas. And also, Wikipedia was also involved, of course. I'm a big fan of Wikipedia. I just found out apparently there's a Wikipedia article called Why Wikipedia is So Great. And to their credit, well, technically it's an essay, not really an article. They make a difference, they make a distinction. There's also an article, Why Wikipedia is Not So Great. Anyhow, Wikipedia, it's good. I like it. So it probably doesn't surprise you that if we're going to give credit for the idea of the conservation of momentum, that credit would go to Isaac Newton. Um, yeah, major character, probably the main character in, definitely the main character in the physics you're learning in Physics 1 or you learned in Physics 1. So yeah, probably the most important scientist ever. He wrote the Principia back in 1687. Very important book, leads to the scientific revolution and therefore the industrial revolution and therefore the modern world. Um, One thing to point out, though, is he didn't actually understand the difference between momentum and kinetic energy. So he didn't use the word momentum either. He called it the quantity of motion of a body. So as brilliant as he was in so many different areas, he didn't actually get the idea that uh, the quantity of motion of a body, it's kind of what we now think of as momentum, but he didn't really get the idea. He didn't understand the difference between that and kinetic energy. So if we're going to give credit for the idea of the conservation of energy, surprisingly, we should probably give it to this person, Emilie du Chatelet, which is someone I don't think I had ever heard of before yesterday. So a very important scientist and also philosopher and author and translator and many other things. And I don't think I had ever heard her name at all until I was watching that Sean Carroll YouTube. Um, but yeah, worth looking into her. I read about her on Wikipedia and watched a little short YouTube about her. Um, but yeah, very important, very well respected in her time. Had a relationship with Voltaire and came up with some very important ideas that are still influential in physics. So if we're going to give credit to this idea that energy is conserved has been around for a long time, but she came up with one of the keys that kind of led us to its modern form. So yeah, she translated and commented on Newton's Principia. Um, she finally finished her translation in 1749, which was the year that she died. It wasn't actually published until a decade later, apparently. Um, but yeah, in her commentary on this, she translated it from Latin into French. Um, yeah, she really explained the difference between momentum and kinetic energy. Newton would not have understood. I mean, he understood momentum very well, but if we look at this, uh, yeah, momentum is just directly related to velocity. What Newton didn't really understand is that there's another similar but different idea, uh, kinetic energy. At the time, they would have called it vis viva in Latin. That is proportional to velocity squared. So that's a very key idea that Newton didn't get. Emilie du Chatelet did figure this out, and commented on it in our translation, and led to a lot of important physics. And if you're in Physics 1, it led to a lot of the ideas that you just learned. So the last slide in this little mini presentation, we're going to compare and contrast these ideas. So obviously, they look very similar. Conservation laws should all kind of look this way. Whatever amount of the thing you have at the beginning, here on the left-hand side, you will have it on the end. That holds true whether you're dealing with momentum or whether you're dealing with energy. So the conservation momentum clearly deals with vectors. These things are wearing hats. These are vector hats. Only vectors wear the hats. Whereas the conservation of energy deals with scalars. And mathematically, that's kind of important to the other things that are going on here. So I kind of knew this, but never really had this idea so clearly stated as in reading about Emilie du Chatelet, that momentum can't be transferred into different forms, and there's no such thing as potential momentum. Momentum can be given from one body to another, and you can have perfectly inelastic collisions where they had it separate and now they're sharing it, and you can have explosions where they had it all together and now it's in separate places, but you can't transfer it from one form to another. Whereas energy you can transfer. This is something Newton and his contemporaries like Leibniz was in this article too, didn't really quite get. Leibniz apparently did some work where he realized in some situations kinetic energy is conserved, although that's not in general a rule. So Chatelet kind of built off his work and went further with it and really kind of crystallized this idea that not only is there a thing called momentum, there's also this thing called kinetic energy. Momentum is proportional just to V. Kinetic energy is proportional to V squared. And again, momentum is always conserved. Kinetic energy is not always conserved. Total energy is. That's this idea up here. So that was a very important idea that she really deserves credit for. And I don't know why I had never heard of her before yesterday, or if I had forgotten about her. But yeah, very important person, early female, hero in STEM, hugely famous at the time. Apparently, I don't know why history she's kind of disappeared a little bit, but corresponded, had a romantic relationship with Voltaire, and a working partnership with him too for many years. He was the writing guy. She was the math and sciencey girl, partner in that little partnership that they had. But yeah, she also corresponded with like Frederick the Great, and was hugely important. Got papers published. Very important scientist at the time, and I don't know why history has kind of forgotten her, but it seems like it has. So hopefully you found this interesting. I'm going to include links to the Sean Carroll video. I recommend looking at his stuff. And also to maybe a video about Emilie du Chatelet, and also to the Wikipedia article about her. So I hope everyone's doing well, and I look forward to starting remote learning very soon, on Monday, apparently.